Industry analysts identify the first half of 2026 as the final cheap learning window for AI experimentation. Organizations that fail to integrate AI-first tools by this quarter face a technological gap that will effectively become a permanent competitive disadvantage. Within this window, AI-native systems have moved to the center of operations, acting as the mission-critical structural layer for all software delivery. This environment has redefined the role of the engineer. High-performing teams focus on expressing intent, articulating a desired outcome rather than manually assembling the steps to reach it. Once that intent is defined, AI-native systems handle the underlying integration and maintenance required to sustain the service. Reaching this state requires an agentic reality check. True success in 2026 comes from redesigning operations around these capabilities, because automating a broken manual process only results in a more efficient failure. The transition to these sophisticated internal developer platforms is only possible for teams that have mastered the technical prerequisites found in traditional DevOps competence models. AI-driven orchestration is not a replacement for the CI/CD pipeline. It is a layer of enablement that requires a rigorous organizational bedrock to function. We can map that bedrock using the Utrecht University DevOps Competence Model. It uses a software house framework to visualize the specific technical requirements for organizational maturity. The house is built on a foundation layer composed of 3 core blocks: configuration management, architecture alignment, and infrastructure. Stability in this foundation prevents configuration drift. When the infrastructure and architecture are perfectly aligned, software moves predictably across the stack. Resting on that foundation is the DTAP street, the sequence of development, test, acceptance, and production environments. Maturity within this street depends on continuous feedback loops. It begins in the development block, where branch and merge strategies feed directly into automated build processes to catch integration errors. The loop continues forward. Code moves through test automation and deployment automation to reach a stable production state. The final loop is the incident handling cycle. It captures usage data and system behavior from production and feeds that intelligence back to development and product management. Without this continuous DTAP feedback loop, AI agents lack the environment they need to operate. They simply accelerate the creation of silos and integration failures. The structure is capped by the culture and collaboration perspective. This roof includes trust, team organization, and knowledge sharing. Technical pipelines depend on this cultural alignment. If the internal dependencies between teams are not structurally sound, the delivery process fails. We can measure this cultural maturity in discrete steps. Within the communication focus area, organizations must climb a specific ladder of capability. The lowest level involves indirect communication across silos, often mediated by managers. Maturity starts when leadership begins to provide facilitated communication, creating dedicated space for teams to interact. The next step is direct communication. At this level, developers and operations staff establish personal contact to resolve issues without waiting for managerial direction. The highest state is structured communication. Interdisciplinary teams use formalized protocols like daily stand-ups and retrospectives to maintain a constant flow of information. This human alignment is non-negotiable. An AI-native system cannot orchestrate a team's intent if the teams themselves lack the structured protocols to govern it. Organizations reaching full maturity now operate under the Q2 2026 industry baseline. The software house has been upgraded to AI-native DevOps. This transition replaces rigid, rule-based execution with adaptive, learning-driven workflows that evolve as they process data. At the foundation, this requires the deprecation of handcrafted infrastructure as code. The 2026 standard is intent-driven infrastructure. Engineers define the required target state, and the platform autonomously handles the provisioning and scaling. Error handling undergoes a similar transformation. The reactive process of manual, alert-heavy log scrolling is no longer sustainable. Intelligent Ops utilizes AI-driven pattern detection and autonomous remediation, neutralizing system anomalies before they manifest as service interruptions. This upgrade is essential for managing multi-cloud complexity. Manual IAC pipelines eventually break under the overhead of human maintenance. These capabilities find their ultimate expression in internal developer platforms, or IDPs. By the end of this year, 80% of software organizations are projected to rely on these platforms as a centralized product for their engineers. The DevOps engineer's role has fundamentally shifted. Direct manual execution is effectively a legacy activity. Modern engineers focus on high-level orchestration, AI governance, and the design of rigorous guardrails that keep autonomous systems within safe operating parameters. Project documentation provides the contextual fuel for this assisted delivery. It is the semantic ground truth the AI uses to understand the desired system state. Modern outcome-focused charters replace vague delivery milestones with specific winning conditions, such as achieving a target of 10,000 active users. Professional services automation has also moved beyond the manual traffic light status report. Predictive PSA utilizes AI to identify resource bottlenecks and budget overages weeks before they manifest. This gives leadership the time needed to adjust strategy before a project is compromised. By 2026, the primary competitive advantage is the ability to define intent and govern the AI-native platforms executing it. Success belongs to the organizations that have built the mature bedrock required to lead.